Every morning it rises without fail, the way it has for billions of years. Our sun is a ball of burning gas nearly 1.4 million kilometers across. You could line up 109 Earths across its face and still have room to spare. At its core, the temperature reaches 15 million degrees. There, every single second, it fuses 600 million tons of hydrogen into helium. And it has been doing this, quietly, for about 4.5 billion years. The light warming your skin right now left that surface 8 minutes ago. It crossed 150 million kilometers of empty space to reach you. Almost every living thing on Earth depends on that one star. It is the engine of our oceans, our weather, our seasons. It feels eternal, permanent, unchanging. But the sun is not eternal. It was born. It is changing right now, and one day it will die. To understand how the sun dies, you first have to understand how it lives. A star is a constant war between two enormous forces. The first is gravity, crushing inward, trying to collapse the entire sun into a point. The second is the heat of fusion, pushing outward from the core. For now, these two forces are almost perfectly matched. That balance is the only reason the sun holds its shape. It is a controlled explosion, the size of a star that has lasted billions of years. But fuel does not last forever. Deep in the core, the hydrogen is slowly running out. And when the fuel changes, the balance changes with it. The story of the sun's death is the story of that balance breaking, and it has already begun. Here is something almost no one realizes. The sun is slowly getting brighter and hotter with every passing eon, roughly 10% brighter every billion years. That sounds slow, and on a human scale, it is. But for the planet, it is a countdown. In about 1 billion years, the sun will be hot enough to boil our oceans away. The water vapor will rise and slowly bleed off into space. Earth will become a scorched, lifeless world long before the sun itself dies. The blue marble we know will be gone, and the sun will still have billions of years left to live. Its real death is still ahead, and it will be far more violent. In about 5 billion years, the core finally runs out of hydrogen. Without fusion to hold it up, the core begins to collapse. The hydrogen in the layers around it. The sun's outer layers outward. The sun begins to swell and swell and swell. It becomes a red giant, hundreds of times wider than it is today. First, it swallows the planet Mercury. Then it reaches Venus, melting it into nothing. Its glowing surface expands out toward the orbit of the Earth. From the surface of our dead planet, the sun would fill half the sky. A bloated, red, dying monster where our gentle star used to be. Whether the red giant actually swallows the Earth is still debated. As the sun loses mass, its grip on the planets loosens, and their orbits drift outward. Earth may be swallowed whole, or it may escape, only to be scorched bare. Either way, it is the end of our world. Meanwhile, deep inside the giant, the dying core is not done. The temperature climbs until suddenly the helium itself ignites. In a runaway flash, the core burns helium into carbon and oxygen. The sun pulses and shudders, growing unstable. It begins to pulse off its outer layers in great shells of glowing gas. Slowly, gently, the sun starts to take itself apart. The furnace that gave us life is finally going out. What the dying sun leaves behind is, strangely, one of the most beautiful things in the cosmos. The shed outer layer spread out into a vast, glowing cloud. A planetary nebula, lit from within by the exposed core. Delicate shells of red, green, and blue stretching across light years. For a few thousand years, this ghost of the sun will glow in the dark. And then the cloud drifts away, leaving only the core behind. That core is a white dwarf. All that remains of the sun crushed into a sphere the size of the Earth, so dense that a single spoonful would weigh several tons. It no longer burns. It simply glows from leftover heat. And over countless billions of years, it will slowly fade to cold and black. A dark cinder, drifting where a star once shone. All of this is still billions of years away. We are living in the sun's long, golden middle age. It is stable, generous and kind in a way it will not always be. Every sunrise you have ever seen is a moment inside that fragile window. And there is something else worth remembering. The atoms in your body, the iron in your blood, the calcium in your bones, were forged inside stars that died long before the sun was born. We are, quite literally, the children of dead stars. And one day, the sun will scatter its own atoms back into the galaxy, to one day become part of new stars, new worlds, perhaps new life. Nothing in the universe is permanent, not even the sun. So tomorrow, when it rises, take a moment to really look. You are watching a star in the brief and brilliant prime of its life.